Today we're going to look at rectilinear motion. This is something that you've honestly seen before, and it should be kind of review, but I want to review over some things and put it all together. So average velocity is the average rate of change of a position, okay, which is also the slope of a secant line between the beginning and the ending time. And we've looked at two different things. Average velocity could be this, all right, is position, like the subtraction of the position over the time, okay? Or say we're given the velocity function, okay? It is the average velocity. What we would do is we would integrate velocity, so we would get the position and then divide it by the time, all right? And you see that here. Okay, something else is average speed. Know that speed is positive, so therefore average speed is absolute value. All right. Same thing if they ever ask you for like total distance that you've gone, that's also absolute value. Now, if x of t is the position function, then x prime of t is v of t, the velocity, and x double prime of t, or the first derivative of the velocity, is the acceleration. Some other things to recall is that when velocity and acceleration have the same sign, it's speeding up, and when velocity and acceleration have different signs, we are slowing down. So keep some of these things in mind. And we're going to look at some AP problems today. So let's look at this first one right here. All right, we're looking at 2003 AB, question number 4. Okay, this is going to be without a calculator, so we're going to try to do everything without. Okay, so a particle moves along the x-axis with velocity at time given by, so we see our velocity function, and I'm going to write it up here because I'm going to take the problem away in just a second. Okay, find the acceleration of the particle at time t equals 3. So again, we're going to do this without a calculator. So we want to find the acceleration. Acceleration is the derivative. Now, you have to write that you're taking the derivative of this. Don't put a of t equals, because the readers want to know where this actually came from. Well, when I take the derivative of this, of -1, that's 0. So I just need to take the derivative of this. Well, e is going to be itself, and then don't forget to do the derivative of this 1 minus t, which is -1. So it's negative e to the 1 minus t. Well, we want to know at t equals 3. So now you don't have to write v prime of 3 because you already know what a of t is. And we just plug this in. And you're welcome to write it like this and leave it. Just recall that is also the same thing as that right there. And I'm going to talk about points today as well. So you would get 1 point for showing this right here, and you would get 1 point for the answer. All right, so that's a 2-point problem part right there. So let's look at B. Is the speed of a particle increasing at time t equals 3? Give a reason for your answer. Well, let's recall that. And remember what I said. For speed to be increasing or speeding up, the velocity and acceleration has to have the same sign. Okay, well look, we already know at a sub 3, it's -1 over e to the second, so this is negative. Now let's find v of 3. Well, that's just plugging it in. So -1 plus e to the, -2? So -1 plus 1 over e to the second. And think about this for a second. This is smaller than 1 right here. Okay? So even though we don't have a calculator, we can figure that out. This is smaller than 1, so therefore this is also going to be less than 0. Okay? Instead of saying negative, you can say less than 0. So therefore, a of 3 and v of 3 are both negative, sorry. So speed is increasing. All right, let's look at part C. All right, it says find all values of t at which the particle changes direction. Well, when it changes direction, that's when v of t is going to equal 0. So we say v of t equals 0. All right, and we're solving for t right here. So if I add the 1 over, think about it, I got to get rid of e. So how do I get rid of e? ln. When I take the natural log of that side, it's 1 minus t. Okay, well, what's the ln of 1? 0. Okay, and I can add the t over, and I get t equals 1. All right, now I actually have to verify this. Now I can do a sine line. All right, but remember that's not part of our work, but it kind of helps us out. If I plug in 0, think about that for a second. That's going to be -1 plus e to the first. E is 2 point something, so we know this is going to be a positive. And then here, after 1, say 2. All right, when I plug in 2, this is going to make e to the -1, so it's going to be -1 plus 1 over e, like that. Well, this is less than 1, so this is going to be negative. All right, so we have to say for values of t less than 1, v of t is positive, and t is greater than 1, v of t is negative. Therefore, the particle changes direction at t equals 1. All right, now I didn't say anything about points in part B, so let's go back up to part B and do points. Really, part B is just 1 point. And okay, so you have to have your reasoning, and basically the reason is at a of 3 and v of 3, they're both negative. They both have the same sign. Okay, so if you have something written like that. Now, part C, you get 1 point for solving for t equals 1. Okay, and you get another point for the justification. Okay, again, the sign line cannot be in your justification. All right, so far 1, 2, 3, 4, 5 points. So we have 4 points left for the last part. Okay, so let's look at part D. Find the total distance traveled by the particle over time t. Now, when we talk about total distance, we're talking about how far it goes left, how far it goes right, and so we're going to actually have to use absolute value. So what we're doing is part D. It's going to be, so it says from time 0 to 3, a v of t, but because it's total distance, I need absolute value. All right, well, there was a reason for finding where it changed to the direction, and it changed it at t equals 1. So what we need to do is we need to find where the particle is from 0 to 1, and then it changes the direction, and we need to do it from 1 to 3. Okay, now you can integrate this if you want. I'm going to do it a little easier than that. Instead of integrating those and actually plugging in what v of t is. But what if I find it at x equals 0? Okay, well, I actually have to integrate v of t, and I do still need to integrate v of t. And when I integrate that, that's negative t. All right, now be careful. This is u equals 1 minus t. du equals negative dt. So this is actually, I'm going to need a negative, and so when I integrate that, that's going to be negative e to the 1 minus t. Okay, I can actually find it at 0, when I plug 0 in, I get 0 minus e to the first. Okay, so that's just e. Okay, and then at 1 it turns around. All right, so I got to find it where it is at 1. Okay, when I do that, that's going to be -1 minus e to the 1 minus 1. Okay, so that's -1 minus 1, which is -2. Okay, and then, so it turns around, and then we want to know where it ends at 3. So it's -3 minus e to the 1 minus 3. That's -3 minus e to the -2. If you want to say it as -3 minus 1 over e squared. All right, so if you think about this for a second, all right, your total distance, all right, I've got, and I should have said that's negative, it's negative e. All right, and at first, if you want to, we may need to go looking like this. So here, it's traveling, it's positive, it's traveling right, and then it goes left. So it travels right from here to here. Okay, so we need to say -2 minus -e. All right, and then it travels left from here to here. So then, therefore, from -2, all right, so -2 minus this -3 minus 1 over e squared. All right, now this negative I have to distribute through. Okay, so what I end up with is -2, -2, and 3, which makes a +1. And then I have this e and this 1 over e squared. All right, so this would be the final answer right here for part D. That's a little tricky, or you can actually integrate it this. Basically, the integration from here is this work right here as well. All right, let's look at another AP problem. Okay, we're going to look at 2004, question 3. Okay, a particle moves along the x-axis so that velocity at time is given by, all right, so v of t equals 1 minus tan, inverse tan e of t. Okay, what we need to do is at time t equals 0, the particle is at y equals -1. All right, a lot of times they'll make this note, arctan is tan inverse. Okay, we need to find the acceleration of the particle at time t equals 2. All right, so here we go. Acceleration is the derivative. So when I take the derivative of this, we got to remember what is the derivative of this right here. And I should probably tell you, this one actually is a calculator problem. All right, so when we do this, we just want to know what a of 3 is, or a of 2, because we want to know it at time equals 2. If I take my calculator, okay, and I'm really just taking the derivative of x, and I'm just going to type this in here. I can put it into y1 if I want, okay, or I can just do it like this, and I want to know it at 2. All right, so round it to 3 decimal places, -0.133. It doesn't say anything about units, so I can just leave it like this. And this is just 1 point right here. Make sure you associate acceleration with the v of t. All right, in part B, okay, it says, is the speed of the particle increasing or decreasing at time equals 2? So it's about the same question that we have. If it's the same sign, if v of t and a of t have the same sign at 2, then therefore it's speeding up, or it's increasing. If it doesn't have the same sign, it's decreasing. Okay, so we already know what this is, so we just need to find v of 2. Okay, so 1 minus, all right, inverse tan of e of 2. All right, well, this equals negative 0.436. So since a of 2 and v of 2 are both negative, or you can say less than 0, then the speed is increasing. All right, and again, that's only 1 point. All right, part C. Find the time when t is greater than or equal to 0 at which the particle reaches its highest point. So last time I think it said, did it say something about changes directions? But this is about the same thing. Reaches its highest point, all right, is when v of t equals 0. They give you a point for saying v of t equals 0, okay? And really, so here I can take this and I'm going to clear out everything I've got. They just want to know when this equals 0. So 1 minus inverse tan of e of t. Okay, when does it equal 0? All right, let's say zoom, and I'm going to say zoom 0 for zoom fit, and it'll graph it. All right, and I just want that answer right there. Second trace, 5 for intersect. You probably don't have to scroll all the way to it. If I just press enter, it's probably going to give it to us. So that's at t equals 0.443. Okay, now you get 1 point for this and 1 point for this. There is a third point. You have to justify that this is a absolute max. All right, so therefore, let's see, we can do the sine line. Okay, if I were to plug 0 into here, okay, think tan of 1, let's see, if I do v of 0, be 1 minus tan inverse, e to the 0 is 1. Well, think when tan is 1, it is pi over 4. Okay, so this is positive. All right, so I can do it a little bit by hand. All right, when this is greater than 0.443, all right, let's say, we can just say 1. 1 minus tan inverse of just e. So when that's just 1, okay, if you want to plug it in, 1 minus tan of e to the first. Oops, I did that wrong. I should have done the inverse. And I got to plug 1 in there. Okay, and this is, I'm just going to say less than 0. It's negative. All right, so therefore, okay, when t is less than 0.443, v of t is greater than 0. Okay, and when t is greater than 0.443, v of t is less than 0. Therefore, t equals 0.443 is a max. All right, and we need to look at part D. Find the position of the particle at time t equals 2. Is the particle moving toward the origin or is it moving away from the origin at time t equals 2? All right, well here, where is it to begin with? All right, find the position of the particle at time t equals 2. So that means we're finding y of 2. Well, originally, where was it? It's originally at time t equals 0, the particle is at y equals -1. So it's at -1. And you need to know, where is it at 2? So from 0 to 2, all we have is v of t. All right, so we need to find this amount right here. Well, when I take my calculator, -1, all right, plus, and we've got to do the integral from 0 to 2. We got to put v of t in there because I didn't put it in y1. All right, so rounded to 3 decimal places, -1.361. This gives us 1 point right here. Okay, so there's the position of the particle. Now, is the particle moving toward the origin or away from the origin? All right, so here you get 1 point. Actually, you get 1 point for this and 1 point for using -1 and 1 point for the value. So the second point, or the last point, the fourth point, is it moving away from the origin or is it moving towards the origin? All right, well here, what is v of 2? The velocity. The velocity tells us if it's moving left or right. Okay, so I need to find this value right here. Okay, and this is -0.436. If you notice, this is in the, and think about this on a number line. Okay, -1.3 is right here. Okay, well, because the velocity is negative, it's moving left, so it's moving away from the origin right there. So since y of 2 is less than 0 and v of 2 is less than 0, all right, the particle is moving away from the origin. All right, and lastly, for the last one, I'm going to put up the question and then I'm going to put up the answers. All right, and not actually work it out here. So here's the question. Freeze it to see if you can do it. All right, and now here is the answer, and you can see how they do the points here. It's very similar to the ones that we just did. Okay, so there's the full answer. You can see how where you get your points from. If you do not set v of t equal to 0, you're not getting that point. You have to identify 1 and 2 here, and you have to give a reason. Okay, remember, sign lines don't give you, is not part of the work, but you can use it. All right, here you get a point for the integral. All right, but you get a point for using that initial condition of 8. Okay, and then you get a point for the answer. And then remember, average speed is absolute value. Okay, so you have to have the absolute value here. You get a point for the integral, and you get a point for the answer.